Welcome back to the course Corrosion Failures and Analysis, and today is 7th lecture and we talk about galvanic corrosion. So, we started discussing galvanic effect in our previous lecture. So, this will continue. So, the course is Corrosion Failures and Analysis, and this is lecture 7 and topic galvanic corrosion. Fine. Now, while talking about definition of galvanic corrosion, we said that one strong characteristic of galvanic corrosion is there should be preferential location of cathode and anode. An usual definition in the book as it is written that two metals or alloys of different electrochemical activity or behavior showing corrosion of one part when they are electrically connected and exposed to electrolyte. And we have also seen that this definition is not all about galvanic corrosion. You have to consider this part, there would be a preferential location of cathode and anode. Fine. Now, let us get to the usual galvanic. Whenever we talk about galvanic corrosion, we start with voltaic cell, okay, or zinc copper cell. So, now we see that galvanic corrosion has one definition part, another the major part is preferential location of cathodes and anodes. Now, whenever we talk about corrosion, we start with a cell which is Daniell cell, which is nothing but two containers. In one we have a copper plate dipped in copper sulphate, and another we have zinc dipped in zinc sulphate. Here copper ion activity is maintained as 1, here zinc ion activity is maintained as 1, or concentration, let us say activity. In terms of activity, if we want to write, we can write this. Okay. This is the electrolyte level. We have one salt bridge which allows charge flow. Here it is a basically exchange mechanism, these are electrically connected, and now if we try to measure its potential with reference to standard hydrogen electrode, and this is also connected to another standard hydrogen electrode, okay, and this path is high resistance path. So, very little current flows between these two connections, only it measures the potential of these two electrodes. this potential is developed, you would find after stabilization, you would find this potential becomes 0.34 volt and this becomes around 0.76 volt. Okay. And this is minus, this is positive. You will see the minus positive all those. And here we are only talking about reduction potential. In fact, the entire discussion of this course will be on the basis of reduction potential. Now, when we have this, we have this potential. Now, if we connect this with a conducting wire, we will see the current will flow, and if we have a ammeter connected to this, you will see that the current flow would happen from this end to this end. This is the circuit current. And we will see that the zinc will gradually deplete and our copper would gradually increase. And here the copper ion here present, the copper ion will take 2 electron and deposit on copper plate, and in this case zinc will release 2 electron and then go to zinc plus ions. So, that way this is corrosion of zinc and this is deposition of copper. And if we see the voltage here, this cell voltage, the cell voltage would be 0.34 minus 0.76, it would become 1.1 volt. Okay. So, this is the cell voltage to start with. And if we see the galvanic condition, delta G would become minus NF E cell, which is delta E cell would be 2 minus 2 into 96500 into 1.1 volt. So, this becomes negative. That means, this process what we are saying, this is spontaneous process. Now, here zinc would corrode spontaneously and copper would deposit spontaneously, and if you maintain this ion concentration, you would see that copper will keep on depositing, okay, and the zinc will keep on dissolving. So, this is one galvanic effect, okay, and copper zinc is corroding. Now, interestingly, if I see the observation is they started with their own ions. So, in copper side we had copper ions to start with, and zinc side we had zinc ion to start with, but still we could see that this preferentially the cathode, this becomes cathode. We have already seen that in the previous set of lectures. So, this is cathode and this is anode, and interestingly this will remain anode, this will remain cathode. So, again it is a preferential cathode and anode positioning. So, this is a typical galvanic corrosion. Now, let us take, this is example 1. Let us take another example. Now, if we have pure HCl, we dip one zinc plate, zinc block, and if we, let us say zinc block is hanging and you have actually hooked it and connected to the bottom mowing facility, you would see that this zinc weight would reduce. Fine. And we would observe that there are the bubble formation. bubble formation, fine. Now, and if we see, and this is insulated, so this connection is insulated, remember. So, that means here we do not have any two metal connection, because this, since this is insulated, that insulated part is not getting in contact with the electrolyte, and so let us say this is copper. So, or you can use a thread, polymer thread, or a simple cotton thread. Okay. So, then there is no question of galvanic effect, because two metal effect. And here we have two reactions, one is zinc 2E, zinc plus plus, and H plus 2E equal to H2. This is anode and this is cathode, fine. We will see that this bubble formation is uniform over the entire surface. Entire surface, and zinc dissolution is uniform over entire surface. So, there is no preferential locations, but interestingly, if we do the same experiment by putting two blocks, one is iron, one is zinc, and we same way we hang it with a cotton thread, and we keep taking weight, and here again initially to start with you will see that what are the observation you would see? You would see that the weight and these two are electrically connected. How you can do that? For example, you take one block of iron, you have taken, another block of zinc you take, and then keep a screw here, and here also the screw will enter into this. Okay. So, you can make a thread screw connection, and then that way you can tightly connect both of them. And interestingly, when you connect, this screw material does not make any contact with the electrolyte, because that is covered up by the entire zinc and copper surface, zinc and iron surface. So, this is electrically connected, but at the connection point, if you are doing it with a kind of screw tightening situation. Okay. So, you can make a nail, that nail is dipped into this. So, this is actually with the iron, and now this on top of it you press fit the zinc, this is iron. So, that way you can connect. So, this part will not come into contact with the electrolyte. So, this is electrically connected. So, weight of the entire assembly would decrease gradually. Similarly, in the beginning bubble, so this is also HCl, let us say pure HCl, bubble of hydrogen would form on both the surfaces, no preferentiality, but after some time you would see bubble of hydrogen would be preferentially located iron surface, and interestingly on zinc surface hydrogen bubble hardly forms. Fine, maybe one or two bubbles, but otherwise you can distinctly see that on the iron surface you will have lot of bubbles, but on zinc surface you will have less bubble. And after you take it out and then open this screwing, you would see that zinc weight loss would be considerable, but iron weight loss would be there, but very small. So, these are the three observations we would see. All those observations have checked one by one. Now, in this case it is very clear that the bubbles are forming, which is hydrogen bubble, which is coming due to cathodes, and the zinc dissolution, if you take it out, this zinc plate, and if you see the cross section, the zinc is actually corroding over the entire section uniformly through the depth direction. But in this case you would see that this is the iron and this is zinc. The zinc is actually corroding more here and less around the other part, but here would be more, and iron, the corrosion would be, again there will be corrosion, but a very small amount, and that corrosion also would be located close to that zinc plate, but zinc would be corroding more where the iron plate is connected to zinc. And one more condition, just I missed it. Remember, when you connect, make sure that the area of both iron and zinc blocks are same. So, that means the same area is exposed to the electrolyte. So, this is very important, remember, this is very, very important, very important. Now, interestingly, initially this particular observation, see, weight loss, the total assembly weight loss is taking place, which is absolutely fine, because zinc is corroding. We could see that zinc is gradually decreased, and then finally if we take it out and analyze, we will see that zinc is corroding heavily. Oh, sorry, here I made a mistake. So, zinc corrosion would be more in these segments, because the center part is not exposed. So, the corrosion will gradually happen from the surface to the center part, is not it? So, that is what the zinc corrosion would be more where the joining is taking place. So, like this, it will go like this, it will progress like this, it is progressing like this. Okay. So, this is zinc part and this is the connector, and we have to consider that when we do this experiment, we have to also keep both these blocks to be same size, same area, remember, same area. Now, first observation, it is not sufficing, because weight is decreasing, because both, and after checking this we could see that both iron and zinc is dissolving. But the situation becomes different. In the beginning, bubbles of H2 will form on both the surfaces, but after some time you will see that the iron surface bubble of hydrogen would be preferentially located, and on the zinc surface hydrogen bubble hardly forms. And if hydrogen bubble is forming, that surely indicate that this cathodic reaction is taking place, and we know this is cathodic reaction, and we know wherever cathodic reaction takes place, that is cathode. So, iron is acting like a preferential cathode, and since zinc surface we do not see hydrogen bubble, that means cathodic reaction or hydrogen evolution reaction is not taking place it surely indicates that in order to maintain charge balance, these electrons need to be supplied. So, this supply would come from zinc surface, and the zinc surface would corrode preferentially. And whichever corrodes, we call it anode, and the anodic reaction would happen there. Now, if we compare both this process where zinc only dipped in HCl and where iron and zinc are combined and dipped in HCl, same acid concentration, we would see that in the case also we have two cathodic reactions, two reactions, one is cathode, another is anodic reaction. So, this is cathodic reaction, this is anodic reactions, which is zinc dissolution. Here also I do not see any difference. Here also I see the cathodic reaction is this is cathodic reaction, and anodic reaction fine. So, both the cases I have same reactions to make a complete electrochemical cell, same reactions, but the positioning of cathodic and anodic reactions are actually leading to a localized or preferential corrosion of one object and the protection or the less corrosion of another object. And another important aspect is wherever cathodic reaction is taking place, that means in case of here it is iron surface, the iron is not going to the solution, but zinc, since there is no cathodic reaction, zinc is going to the solution. Okay. So, the zinc preferential corrosion is taking place. Now, in addition to this, one important aspect, if we only dip iron here and measure the weight, same HCl, and this is iron, you would see iron corrosion would be considerable, and this corrosion phenomena would be exactly same as zinc corrosion when zinc was dipped in the same acid individually. Okay. So, that means this phenomena and this phenomena will be same. Here also iron will dissolve through this reaction and cathodic reaction happen. So, this reaction would happen, but the major difference is coming here because of these two metal connections. We have one surface to be preferentially cathode, one surface is preferentially anode. And another important aspect what we are seeing, that initially to start with in all those experiments we never had any zinc ion or iron ion to start with. So, that means this is different than the process what we have considered in case of galvanic corrosion of zinc in Daniell cell. Okay. So, that means we have to talk about the preferentiality of cathodes and anodes, and at the same time whenever that preferentiality comes, one part becomes cathode, another part becomes anode, and then the anode part would dissolve, the cathode part would not dissolve much, because here if we dip iron individually it corrodes heavily, but once we connect it to zinc and dip it in the same acid, iron corrosion is suppressed and zinc corrosion goes up to a great extent. Okay. So, we will discuss this these three experiments, virtual experiments what we have done, we will discuss this in our next lecture, okay, where we will talk about the mixed potential theory along with it, and that time you would understand that galvanic corrosion does not mean that the corrosion of one component which is cathode is stopped. It happens, but it happens at a much lower rate than the other anode component. So, that is one of the important aspects of galvanic corrosion. So, let us stop here, we will discuss in subsequent lectures. Thank you.